Today's lesson is operations with linear functions. We can perform arithmetic operations with functions similarly like we do with numbers, such as addition, subtraction, multiplication. For example, given that f of x is 3x minus 1 and g of x is negative 2x plus 2. Find h of x, which is the sum of f of x and g of x. So what you're going to do is, f of x is 3x minus 1. So I'll put 3x minus 1. And we're going to add that to g of x, and that's negative 2x plus 2. And since it's addition, you can go ahead and just add like terms. So I have a 3x, I'm going to add that to a negative 2x. I have a negative 1, I'm going to add that to 2. So 3x plus negative 2x is just x. And negative 1 plus 2 is just simply 1. So that's what h of x is when you simplify by adding the two rules from the previous functions together. All right, subtraction. Be a little careful with subtraction. The order matters. So if we're given that f of x is x plus 5 and g of x is 4x minus 2, you want to find h of x. We're going to say f of x minus g of x. So when you do this, f of x is x plus 5. That must come first, and then minus. Then g of x is 4x minus 2. Always change the sign of the numbers to the parentheses, to the left of the parentheses of the minus sign. For example, and to the right. So this will be minus 4x. This is plus 2. Don't forget to change that to positive 2. We have x plus 5 minus 4x plus 2. And then now you can simply put like terms together. I like to think of this as a plus negative 4x. So I'm going to say x plus negative 4x, and then plus 5 plus 2. All right, so x plus negative 4x is negative 3x, and 5 plus 2 is 7. This is what h of x is when you subtract it. All right, multiplication of a non-zero constant to a linear function. So notice I didn't have two functions multiplied together. I'm talking about a constant function. F of x is 2, and g of x is 1/2 x minus 2. If I want to know the product of those two, let's see, that makes up h of x. I would do this. So f of x is 2 times, and g of x is 1/2 x minus 2. We're just distributing this constant into this linear expression. So look, 2 divides into itself once, so you can get x, and then 2 times 2 is 4. So h of x is x minus 4. If you have two linear functions and you multiply it together, you would not wind up with another linear function. I want to talk about function composition. That's just simply substituting the rule of one function into the rule of another function. We often use this symbol here. Let's say we have f of x and g of x. You'll see this symbol. That's not multiplication. That's the composition functional. So that's read f into g. Or it's written like this. All right, for example, if you're given that f of x is x plus 5 and g of x is 4x minus 2, and they want you to find the composition of this. So have f with g. That's the same thing as this. What I'm going to do is I'm going to take the rule of g and I'm going to apply that to f. What do I mean by that? So we know that f of x is x plus 5. I'm going to substitute x with 4x minus 2. So what we'll do is this is just simply equal to, you're going to write the rules down. Instead of x, I'm going to put 4x minus 2. And then I'm going to add 5 because that's the rule that comes with f of x. Then you just simplify. So we have 4x minus 2 plus 5. So we have 4x plus 3. That's what this is. This is not always commutative. Most of the time it's not. For example, if we switch it the other way around, you get a different result. So let's say I went the other way around and compose g f into g. What we're doing is g of f of x. So now I'm going to replace x with x plus 5. And I'm going to substitute that into this rule. So now I have 4 times x plus 5 minus 2, because that's what the rule says with the function of g of x. We're going to distribute this 4, so you get 4x plus 20 minus 2. So that's 4x plus 18. And that's what this is, which is different from the other function. So it's not commutative when you use this operation. This concludes our lesson for today.